This presentation is on climbing ripples and dunes, brought to you by Group 4. We will be describing the features and processes that are responsible for the formation of these sedimentary structures, as well as what flow regimes that these structures occur within. The primary feature responsible for the formation of climbing ripples and dunes are ripples. Ripples are formed when the fluid flow over a bed has sufficient energy to move the sediment and deposit it in an area of lower energy. From the image, it can be seen that asymmetrical ripples are formed when the fluid flow is in a single direction. Asymmetrical ripples have a characteristic that the leeward side is steeper than that of the stoss side. Thus, when the sediment reaches the crest, it is deposited on the leeward side where the energy is lower. When the fluid moves back and forth over a single bed, symmetrical ripples are formed. Thus, depending on the direction of the flow at a particular time, depends which side is the stoss and which side is the leeward, and thus where the sediment is deposited. Dunes are formed in the same fashion that ripples are, where sediment is brought up the stoss side and deposited on the leeward side. Where dunes differ from ripples is in their magnitude. Where ripples commonly have a wavelength of around 20 centimeters, dunes can have a wavelength in the tens or hundreds of meters.
Climbing ripples and dunes. Climbing ripples form when several formations of ripples are superimposed on each other, making these structures record both migration in the horizontal direction and climb in the vertical direction. The same concept applies to dunes, where the movement of sediments on top of each other generates stratigraphic surfaces that are tilted in an upcurrent direction, as seen in the image on the right. There are three different types of climbing ripple structures, which is based on the angle of climb. Climbing ripples can be classified as subcritically climbing ripples, critically climbing ripples, and supercritically climbing ripples. Climbing structures are formed when deposition takes place very rapidly during the migration of ripples and dunes. The conditions required for formation of these structures include abundant sediments in suspension. This is because these sediments can quickly deposit and preserve original layer of ripple and dunes. Furthermore, the supply of sediments must combine with enough of a flow velocity and mean size to control formation of climbing dunes and ripples, which will be discussed further later on. Deposition of these features occurs in areas such as river deltas and floodplains.
From phase diagram, it has the mean flow velocity on the y-axis and the mean sediment diameter size on the x-axis. It tells us about the control of sediment transport and the formation of bed forms. Both ripples and dune with angle of climb are classified in the low flow region of the bed form diagram. In this particular velocity window, it means that the flow conditions were not very fast, but also just had the right energy to transport the sediments. For any ripple or dunes, regardless of the angle of climb, they can occur in various environments and can also be varying in grain sizes to illustrate that they can be formed in a whole range of different environments, such as in the deserts, in the riverbeds, seafloor, or also under stability current flow, which is a gravity flow of seafloor sediments. So one of the most essential factors in identifying the climbing ripples or dunes is the angle of climb. It can tell us a lot about the processes during the formation of a particular sedimentary structure and its deposition environment. Therefore, it is very important to take into account all the various parameters when interpreting the deposition environment, because ripples or dunes only are not enough to make an absolute decision of what a deposition environment was, but they can be used as a tool for simplification.